Hello, my name is Gonzalo-Tancredi. I'm collaborating with some colleagues from the Physics Institute and the Computer Science Institute of my university in Uruguay. The title of my presentation is Propagation of Impact-Induced Seismic Waves into the Interior of a Rubble-Pile Asteroid. The motivation of this presentation is to study the effects of impact waves into the interior of a self-gravity body, and in particular, the dependence of the wave speed with increasing pressure in the interior. Because for an agglomerated asteroid, the pressure could be very low because it could form change forces into the interior, and the pressure could be even zero, as in this hypothetical case. To analyze this effect, we have followed two approaches. One is to do laboratory experiments in Earth gravity, and we also do some numerical simulation with a DEM code. For the laboratory experiments, what we have done is to create this experimental setup where we have a box filled with granular material. It could be glass beads or sand, and we can impact a projectile, or we can put a shaker on top of this to produce some waves. What we have seen is that either in the impact or the shaker experiments, we observe a strong dependence of the velocity of the wave with the confining pressure, as you can see in this example, and similar behavior have been seen either in the impact and the shaker experiments. Also, we have done some numerical simulation using the code. The numerical code is this particle, where we have create a box with 300,000 particles with size between 2 and 5 millimeters, and impact with a projectile of 5 millimeters with impact speed from 50 to 500 meters. And also we have done some simulated shaker. In these experiments, you have seen the propagation of the waves, and we can compute the velocity and the dependence with the confining pressure. Because of this numerical experiment, we can have up to 7 orders of magnitudes of confining pressure, and you can see a strong dependence and a asymptotic value of the velocity when we approach a pressure close to zero. The conclusion of this presentation is the following: that we have observed equivalency between the impact and the shaker, and an increase of the wave speed with the confining pressure with the above formula. This has important implications for the DART experiments. In particular, we would expect very low impact induced seismic waves and a velocity of the order of a few hundred meters and time travel of a few up to a few seconds.